Is it okay? So in that way, so first to 4s2 up to, and then 3d 1 to 10. So there are 10 groups here, and then comes 4p 1 to 6. There are 6 groups like that. So next, the fifth period will add. So here 5s2 will fill. Then 4d 1 to 10. This is 4d 1 to 10. Then comes 5p 6, something like that, right? So when I say that, I'll take this. So this is 5s1, 5s2. Then here 4d, 4d1 to 4d10. And here 5p1 to 5p6, like that. Then how about sixth period? Now when we take the sixth period, okay, 6s2 will fill. After 6s2, 4f 1 to 14. Correct now? So this is the position of 6s1 element, outermost 6s2. After that, actually one electron goes to 5d1. Okay, one lanthanum it is 5d1. After 5d1, it is now 4f40, 4f1 to 14, like that. Is that okay? After 5d1, the break starts from here. Is it okay? 4f1 to 14. Let me group like that. So 14, 4f1 to 14, 14 elements are there. Is that okay? Now 4f1 to 14. After that, it is cerium. This is lutetium. 4f14 is lutetium. Then it will go to this position. After 4f14, this here is a position of the element with 5d2. Then 5d3 goes all the way up to 5d10. Then 6p1 up to 6p6. That's all. Is that okay? After 6p, so electrons enter into 7s2. After 7s2, 5f1 to 14. Correct? After 5f1 to 14, 6d1 to 10. Then 7p6. That's how exactly. So when I take up this position, okay, this is the position of an element with outermost electronic configuration 7s1, 7s2. After that, one electron goes to 6d1. This is actinium. Then the break starts. I'll put a double dot here. Okay. After 6d1, here it is 5f1. Goes all the way up to 5f14. After 5f14, this is thorium. This is lawrencium. This is lawrencium. After lawrencium, it comes back to here. Hafnium, and this is zirconium. This is 6d2. That's all. The break is between 61 to 62. 14 elements of 5f1 to 14. After that, 62. Then 62 after that, this is 63, 64 goes up to all the way up to 6d10. After 6d10, it is 7p1, 7p2, 7p3, like that up to 7p6. This is how D block and F block elements are. They're filled here. So the overall picture. Okay. Now, since D block elements are present from fourth period onwards. Now we have got the reason also why D block elements are present from fourth period onwards. That's because D block elements, if it has to be in an atom, if D orbital has to be filled, that atom must have to be having 4 shells. Correct? No, if 3D has to be filled, that atom must have 4 shells because 3D fills after 4s. An atom having 4 shells belong to fourth period. So first 3 periods, first, second, third, doesn't have D block elements at all. So what do? We'll remove this line. This is little. One second. Okay, so this is how things happen. So this is how periodic table has got its shape. First three period doesn't have any elements in between, for the reason that there is no D block element that is being filled there. So what is that we can conclude now? D block elements are present from fourth period onwards. Okay, they are present from fourth period onwards. Like this. Now, in fourth period, D block elements are there. Fifth period, sixth period, seventh period. Whereas F block elements, they start from sixth period. You can see they start from sixth period. F block. And they are in seventh period also. So sixth period from 5D1 to 5D2 is the break actually. Okay. So that is where exactly. So this is 5D1 is lanthanum actually. La is lanthanum. After that, it is osmium. If you think from lanthanum to osmium atomic number difference is only one, it is wrong. Because after lanthanum, 14 elements from 4F1 to 14 will fill. This 4F1 element is cerium. And the last element, 4F14, is lutetium. After lutetium, it comes back to 5D1, 5D2, that is hafnium. So from lanthanum to hafnium, the gap is atomic number 14. 14 atomic number elements. That means there are 14 elements which differ here from lanthanum to hafnium. It is not the continuous atomic number. Is that okay? So of course, hafnium onwards, it continues with filling up of D electrons. Penultimate. Likewise, when it comes to here, 6D1 is actinium, Ac. After actinium, the element which is present is rutherfordium. Okay, actually actinium, this is rutherfordium. After actinium, rutherfordium, but it looks as if there is continuous atomic number, but it is not so. After actinium 6D1, 5F1 to 14, 14 elements are there. So this is 5F1 is thorium to lawrencium, LR. Okay, cerium to lutetium, thorium to lawrencium. Thorium to lawrencium, 5F1 to 14 fills. After lawrencium, again back with rutherfordium 6D2. Then it starts filling penultimate D up to 6D10. Okay, this is how exactly electrons are filled into D and F block elements. So if I say this is the 4F1 to 14. There are 14 elements which are obtained from sixth period, which are kept after lanthanum. That's why they are called lanthanides. Okay, next 5F1 to 14. These are the F block elements where 5F1 to 14 orbital is filled. These 14 elements which are kept after actinium are called actinides. Or actinoids, they say, lanthanoids, they say, no problem. So actinides basically are from seventh period. Correct? Lanthanides are basically from sixth period. So how do we therefore define lanthanides? Lanthanides are a set of 14 elements in which 4F1 to 14 is filled, which follow lanthanum. Actinides are a set of 14 elements in which 5F1 to 14 is filled, which are kept after actinium. So lanthanides and actinides are F block, whereas lanthanum and actinium are what? Lanthanum and actinium are F block or D block?
F block.
Lanthanum and actinium are F block or D block?
D block.
They are D block. Lanthanides and actinides are F block. Okay, so you can say lanthanides, they start with cerium, go up to lutetium. Actinides, thorium to lawrencium. So you can remember this as Silutola. Silutola in Kannada, Tola, wolf. Silutola, Silunai, Silutola, they say. Generally,
Sir, Tola is not wolf, sir.
Indian okay?
Jackal.
Jackala.
Out.
Okay, I may be not right. Okay. So, sealed thola, generally the word sealed we use in Kannada for the animals from the forest. Okay, so sealed thola. So in that way, cerium to lutetium is lanthanides. Thorium to lawrencium is actinides. Okay. So this is how exactly. Okay, so fine. We'll get back to this now. Which are the elements present in this 3D and 4D, 5D, 6D series like that? Okay, before that, so you should remember now from fourth period onwards, 3D fills. That means D block elements are present, fourth period onwards, right? So now in fourth period, D block elements in which 3D 1 to 10 fills are present. In fifth period, D block elements in which 4D 1 to 4D 10 are filled. In sixth period, D block elements in which 5D 1 to 10 are filled are present. In seventh period, D block elements in which 61 to 6010 are filled are present. So totally D block elements, they start with fourth period, but how many periods they are spread into? 4 periods. And in fourth period, the D block elements with 3D 1 to 10 are present. No, they are called 3D series elements. Next 4D series, next 5D series, next 6D series. So there are 4 series of D block elements: 3D, 4D, 5D, and 6D series, respectively belonging to 4th, 5th, 6th, and 7th periods of the period. So 3D series is not present in third period. 3D series is present in fourth period. 4D series is present in fifth period. 5D series is present in sixth period, like that. You should remember. Because penultimate D is always correct. Is that okay? So let us indicate the last and first element of each series of D block. Okay. So see, the first element of 3D series is scandium. And the last element is, which is this position? Zinc. Okay. And the next one is yttrium is Y. 4D1 is yttrium. That means 4D series starts with yttrium. So after yttrium, zinc, cadmium, this is. Lanthanum, after that it is mercury after cadmium. Mercury. Actinium, I think I wrote the, no, copernicium is. Cn, copernicium. Copernicium. So scandium to zinc, 3D series, where 10 D block elements are present, in which 3D 1 to 10 is built. Yttrium to cadmium, 4D series elements, where 10 D block elements are present, in which 4D 1 to 10 is built. And lanthanum to mercury, it is 5D series elements, where 10 D block elements with 5D 1 to 10 is built. Similarly, last one, the 6D series are from actinium to copernicium. So 10 D block elements where 6D 1 to 10 is built. Is that okay? So lanthanides are from 6th period, Cl to Thola. Okay. Actinides are from 7th period, that is thorium to lawrencium. So this much, you know. If you are interested to write something, I can give you some time. Otherwise, I can proceed. Are you writing anything?
Wrote it, sir.
Pardon me?
We finished
sir.
writing.
I didn't get you. The voice is not clear.
So we finished writing.
Okay, good. Okay. So hope all these things are complete. See, some of the basic things, why it is so, why there is a gap, such kind of things you would have been taught, or you would have forgotten, or there may be confusion. So I think now you have got a complete clarity. So there is no D block elements in first three. There is a reason for that also. If D has to be filled, 4s must be filled. If 4s has to be filled, that atom must have to have 4 shells. If 4 shells are there in an atom, they belong to fourth period. Okay, and F block elements are from sixth and seventh period. Okay, right. Now I'll just mention the blocks here. So people have to tell me the first two are yes block. Correct now? This is, let me say, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So this is 3 to 12 D block, 13 to 18 P block, and the last two periods are F. So this is how the elements are kept in the period. So just you need to know the 4 series of D block elements and all. Let us take it further. I was telling this. Okay, let me finish up this for 4 series. So D block elements are placed from fourth period to seventh period. Of period. So there are 4 series of D block elements. There are 4 series of D block elements. This 3D belong to, this is period, this series. Okay, so 3D series belong to fourth period. 4D series, fifth period. 5D series, sixth period, and 6D series, seventh. Okay, so respectively, and the elements. So you just need to remember. Okay. Oh. We have taken the definition of D block elements, elements which contain partially filled d orbitals either in the atomic state or in any of the common oxidation state. Now they are also called transition elements. Why they are called transition elements is what we think. So D block elements.
So can you scroll down a bit?
If this is what you want.
Yes, sir.
Thank you, sir.
You can write to have a little more complete information. You can add the elements also from last to end here. Okay, this is scandium to zinc here. 3D series. Yttrium to cadmium. Lanthanum to mercury. Actinium to copernicium. Actually, it is also called unbium. 112 atomic number. Unbium. Un is 1, by 2. Nomenclature.
Done, sir.
So we shall proceed. These D block elements are also called transition elements. D block elements are also called transition. Now, why they are so called? I think Nikita was telling they have a property similar to that of S and P block. Any other explanation?
Sir, they show a change in properties in moving from the first period to the last period of the periodic table.
What property is changed?
Metallic to non-metallic.
So that's the correct answer. See, S block elements are perfectly metallic elements. What do you mean by perfectly metallic? The metallic property is electropositivity or electronegativity?
Electronegativity.
Metallic property.
Electropositivity.
So electron donating tendency. All metals have a electron donating tendency. That electron donating tendency is electropositivity, which is considered as metallic property. And S block elements are electron donors. They always readily donate electrons, more electropositive. So they are perfect metals. As we move from left-hand side to right-hand side in the periodic table, we end up with 17th group especially. 18th is in many ways exception. So 17th group, they are highly electronegative and they're all non-metals. They're all non-metals. And therefore, electronegativity is considered as non-metallic property. So when we move from left to right, the electron donating tendency will become electron accepting tendency. That is metallic nature change over to non-metallic nature. That change would be significant through D block elements. The change in property from metallic nature to non-metallic nature as we move from left to right in the periodic table is significant through D block elements. That change is significant through D. So that's why D block elements become witness for that transition of properties from metallic to non-metallic. That's why they're called transition elements. Okay. So we can simply write one sentence there. Okay. So from left to right in periodic table, metallic nature changes to non-metallic nature. This change happens significantly to D block. So therefore, they are called transition elements. Okay. Is it complete now?
Yes, sir.
Yes, sir.
See, this definition, this elements which contain partially filled d orbitals either in the atomic state or in common oxygen state is more suitably the definition of a transition element. Okay, it is also transition element is nothing but D block element. But the meaning of transition comes from the changeover of metallic nature to non-metallic nature. As a result, transition elements are more suitably defined as elements which contain partially filled d orbital either in the atomic state or in any common oxidation state. Then how D block nomenclature would be different from transition. Both are same, but if you make a hairline difference, that comes in this definition. Okay, so D block elements are those where differential electron or the last electron enters into penultimate d orbital are called D block. They're nothing but transition, but in a slight way, the definition can be different. Transition elements are those where metallic nature transforms to non-metallic nature. So therefore, transition elements are more suitably defined as the elements where they possess partially filled d orbital, either in the atomic state or in any of the common oxidation state. Okay. However, both D block elements are nothing but transition elements, though we say there is one particular group which differs in these statements. Okay. So let us throw some light on that and understand better. Okay. We'll take some examples here. Before that, I'll just give once again D block. D block means the elements where the differential electron enters penultimate d orbit. Okay. What are transition elements? Nothing but D block, but definition wise, we need to be slightly different. This is already not responding. This transition elements are the elements which contain partially filled d orbitals in atomic or any one of common oxidations. Okay. So now we shall analyze these statements with some suitable examples. Okay. I'll just do one thing. I'll go to next page by taking this step. So we'll take some examples. Let's see whether iron, being a D block element, fits into both the statements. Differential electron enter into penultimate d orbital, and it's also contain partially filled d orbital, so it can be called as transition element as well as a D block element. Iron atomic number 26. Electronic configuration argon 18, 3d6, 4s. 3d6 is partially filled or completely filled?
Partially filled.
Partially filled.
That means iron atom itself has partially filled d orbital. Therefore, the last electron, the 26th electron, enters into penultimate d. Therefore, it is D block. Okay, and it contains partially filled d orbital. Hence, it is transition element. Also, no problem. Okay. Likewise, we can take up now another example. Copper. Atomic number 29. Okay, so argon 18. Actually, 3d9 it has to be, but one electron shifts, so 3d10 4s. Now 3d10 is completely filled, partially filled.
Completely filled.
Full filled. So tell me, 29th electron goes to 3d10. Therefore, it is d block. How about, is it a transition or not transition as per definition?
Not transition.
We can't conclude now because we need to check common oxidation state also. Correct now? So let us go for any one of the common oxidation. Copper exists in two common oxidations. Which are those?
+1 and +2.
Let us check it in +1 whether it possesses partially filled d orbital. Argon 18, does it possess? No. 3d10, 4s1. It is full. Now, can we conclude it is not transition? No, because we need to check in another common oxidation state. So, argon 18, 3d9, 4s0. Now, this is partial. So, therefore, copper is a d block. Because last 29th electron go to penultimate d and a transition element. Because it contains partially filled d orbital in one of the common oxidation states as per the definition. Okay, so no problem. We shall take up next. Zinc will take. Atomic number of zinc 30. Electronic configuration argon 18, 3d10, 4s2. Now it has completely filled. The 30th electron no doubt will go to 3d10. Okay, penultimate d. So it's a d block element. Can I say zinc is not a transition element because it contains full fill? Or any other criteria to check?
Oxidation state.
Oxidation. Which is the common oxidation state of zinc?
+2.
Certain is 2+. In +2 oxidation state, the electronic configuration is argon 18, 3d10, 4s0. So it is still full. Is there any other oxidation state for zinc? Have you ever come across? No. Zinc only exists in +2 oxidation state. It doesn't have any other oxidation state. So what is the conclusion? Therefore, zinc is a d block element. Why do we say zinc is a d block element? Because the 30th electron go to penultimate d orbital. But zinc is not a transition element. It is not a transition element. Why it's not a transition element? Because it doesn't contain partially filled d orbitals. Either in atomic state or the oxidation states, or in the oxidation state. So that's the reason why we say zinc is a d block element and not a transition element. Therefore, we have one statement to make. Therefore, zinc is considered as a pseudo transition element. It's considered as pseudo transition element. So which are the other elements which are similar pseudo transition elements? So you should know that all 12th group elements are pseudo transition. Elements, that is, zinc, next cadmium and mercury. these three elements. Copernicium we don't consider, it's radioactive. So zinc, cadmium, and mercury, they're all the three pseudo transition elements. So they may ask you, what is pseudo transition elements? Why zinc is pseudo transition? Why 12th group elements are pseudo transition? Something like that. So would you like to make notes for this? Or have you written already?
Written, sir.
Okay.
Written.
So this is about, so therefore iron is D block as well as transition. Copper, D block as well as transition. But zinc is only D block because 30th element, 30th electron go to penultimate D, but not transition. Hence it is pseudo transition element. Okay. So come on. If it is done, I'll proceed further. What are we doing in this chapter, D and F block elements? We are going to first study general properties of all the D block elements. Okay, general properties of all the D block elements, like atomic size, high ionization energy, how some properties like boiling point, melting point, size, everything varies like that. Overall, around 13 properties are there. Is it okay? Which we need to study. After analyzing all the general properties, next we'll take up compounds of D block elements. That is potassium permanganate and potassium dichromate. Potassium permanganate and dichromate, the manufacture and the properties, both we are going to study. Okay, so both are very good strong oxidizing agents, and their oxidizing properties, if at all if in acidic medium or basic medium, something. Okay, so that is where exactly some of the F block elements. Again, under F block elements we have little thing to study because it is less explored block, because entire actinides is radioactive. From thorium to lawrencium, entire actinides is radioactive. Radioactive elements generally can't be studied with chemical properties as they are not stable. Hence, we have little about F block elements. We study some general properties. That's okay. Some similar to D block elements. Fine. If you have any clarification to make, you can ask me now. Just 3 minutes left. So before I could take any new concept, I think we'll continue in the next class. So if you have any doubts, you can ask me, or any clarity required. Is it understood?
Sir, why exactly should be D block should be half filled for it to become transition element?
Not half filled, partially filled.
Yes, sir, partially.
See, that's why transition, when would that happen? Transition would happen when D block elements are partially filled, for the reason that only when they are partially filled, they can exhibit variable oxidation state like P block elements. If they are completely filled, like zinc can exhibit only +2 oxidation state. So it cannot exhibit variable oxidation state. So when it doesn't exhibit variable oxidation state, chemically it doesn't behave similar to the non-metals. Or the transition from metallic nature to non-metallic nature will happen only when there is partially filled. Because of partially filled d orbital, there are so many properties which resemble to this p block or non-metals. So the transition happens only when it is d block, that is partially filled, d orbital. If it is completely filled and it doesn't contain partially filled, means it perfectly exhibit only one oxidation state like S block elements, only behave as metals.
Thank you, sir.
Okay.
Sir, can an element have variable oxidation states and still not be transition element?
That's what zinc, no. That's what I was telling. Zinc
Has only one oxidation state, sir.
Oh,
can it be that
what was your question?
An element, can it be that it has variable oxidation states and still not be transition element?
See, by and large, P block elements are so.
Aluminium only. Phosphorus.
But it is not transition, of course. P block elements exhibit variable oxidation state. Okay. Yes. So especially the 17th group elements, when it comes to positive, +1, +3, +5, +7. When you see carbon -4 to +4. Is that okay?
Yes, sir.
Anything else? That's it. Okay, we'll stop at this stage and
Excuse me,
meet
sir.
for the next class. Bye bye.
Excuse me, sir.
Tell me.
Sir, now after 6s, 4f should be filled, no, sir, according to OPCO.
See, these kind of anomalies are often seen in the entire periodic table, especially when you go to F block elements. No, there is a lot of excuses. I remember about 3 plus 6, totally 9 elements have exceptional electronic configuration. So similar to that, even you have some of the elements like palladium doesn't have valence s orbital at all. All the electrons are present in D. Like copper will have one electron shifted to D. The same kind of thing. There are so many factors which will pitch in uh, as to why one electron enters into D and then go to 4f like that. Is that okay? So factors like polarizing power, size, and hydration energy. So all these things results in the stability of that particular electronic configuration. Okay.
Okay, sir.
Some anomalies are still to explain, like F block elements, why it is so. It is a completely, especially actinide series. There are certain reasons to be still explained. Okay. Fine. We'll stop at this stage. Thank you. Bye bye.